Hello, my dear future makers. Welcome to ACE Engineering Academy. ACE online platform welcomes you each and everybody. In today's session, we are going to discuss discrete mathematical structures preparation strategy for GATE 2023 or 24 aspirants. Yeah, my dear students, myself, Vamshi Krishna. Yes, Vamshi Krishna, I am the faculty in ACE Engineering Academy in our computer science department. So without wasting the time, let us move on to the session. So in our discrete mathematical structures preparation strategy, so what are the plan? What is the optimal plan for the preparation? These are the things we are going to discuss. And in our today's session, we are going to discuss the deep analysis of recent papers. And we also see one or two questions, how they are framing the questions from our discrete. And we can understand what is the old pattern of GATE and what is the present trending in GATE. We can analyze all these things in our today's session, my dear. If we analyze in a proper way, then you can prepare our strategy according to that. So without knowing the knowledge about the analysis, so we cannot prepare the optimal plan. I hope you got my point. Let us move on to the session, my dear students. Yeah, students, so this is our GATE 2022 paper subject-wise weightage. So if you observe this subject-wise weightage, here we have the subject like discrete mathematics. Yeah. In our discrete mathematics, we got 13 marks. 13 marks from this area. Yeah. So what we can say is discrete is the one of the highest weightage subjects in our computer science engineering, my dear students. It's not like a pure mathematics. And as we know that discrete is specially introduced for computer science engineering students, and the concepts of discrete helps you to understand the programming and other all computer science areas in a better way. So that is the reason they have introduced discrete for especially computer science. If you observe the mathematics syllabus of other branches, that's entirely different. If you coming to our computer science, it is different, my dear. So here we have the concepts like mathematical logic and pigeonhole principles, graph theory, and Master's theorem in combinatorics. And many concepts are common with the other areas of the computer science. And also we can say that this is something like base, this is something like foundation. If the student is okay with the discrete concepts, then the way of his perception towards the programming is going to be changed, my dear. That is the point you should make it off. Is my point clear? Yes, yeah, that is the thing we should understand. So in that way, we can say that the weightage of the discrete is also in very good weightage it has. Let us analyze the deep analysis of the recent GATE papers. Yeah. So in our preparation strategy, let us take the latest GATE paper, my dear, something called 2022 paper. So in our 2022 paper, we have the questions from different areas, how they touched the areas, you just see this. We got a question from identical balls and identical bins. That is 1 mark question. Yes, in 22 paper, recent paper. And we also have a question, 2 marks question from generating functions. They given some structure, and for that structure, what is the closed form of that generating function it can be, right? So they given some idea, some logic about the sequence. From that sequence, we should understand what is the closed form of the sequence. So we should find the appropriate generating function to the given sequence. So that is one model question we got. And we have a question from graph theory like Peterson's graph. Mm. So what can I say here? Actually, the question seems to be Peterson's graph. But if you actually go into the question, they framed a question in such a way that they given Peterson's graph and they asked about chromatic number. Yes, chromatic number of Petersons. And they asked about maximal independent set. And they asked about Hamiltonian path. They touched many concepts of graph theory in this single question, my dear. So anyway, I can say like this, there is one question framed on Peterson's like this. And we have a question from a recurrence relation. That is a 2 marks question from recurrence relation. Yes, they given some relation f of n in the form which can satisfy that relation, some question we got like that, right? And adjacency matrix of graphs. So from the given graph about adjacency, what are the properties of your adjacency matrix is going to be follow. Such type of question also they framed like this, right? And we also got a question from graph theory like number of cycles. So number of 3 cycles. So I want to find C3, just like C3, cycle of length 3, right? How many C3s are available? How many cycles of length 3 available? So such type of question they framed actually. And we also have a question from connectivity. Yes, they framed a question about what do you call maximum number of edges possible in our disconnected graph, something like that. Some question is available. Yes, and they also framed a question like commutative groups. From group theory, they framed the question like commutative group. My dear student, maybe you can say that the concepts like connectivity, recurrence relations, these two concepts are, they are the common concepts in our data structures and algorithms also. Maybe if you leave at least one question, but we got a minimum weightage of 13 marks, my dear. But if you consider connectivity and recurrence question also in our discrete, then the total weightage is going to be 14 marks. There are 6 questions from 2 marks and 2 questions from 1 mark. Total 12 plus 2, we got 14 marks, my dear. So it's a very good weightage. In GATE examination, getting 14 marks is not at all a normal task. It is not a simple task. So getting 14 marks means you can clear many things. You can clear many things here. Yeah, my dear student, understand the concepts. Not only discussing about the questions came from this area, I can show you the practical questions, how they framed the questions also. So then you can get the complete idea about the questions. Yes. Yeah, let us analyze deeply the recent paper. So this is the question we have. This is the question from group theory. Yeah. Make a look this question. Have a look. Which of the following statements are true for the group? So they given some statements about group. In each and every options, they are talking something like this. If for all x comma y belongs to G, if xy whole square is x square y square, something like this, then G is commutative group. This is one option. And for all x belongs to G, if x square is equals to 1, then G is commutative. This is one more option. And if the order of G is 2, they are talking about something called prime order. If G is equals to 2, then G is commutative. This is one more option. And we have something like this. If G is commutative, then subgroup of G need not to be commutative, right? Yeah, my dear, understand in previous times, when we observe 5 years, 6 years before paper, from the group theory, we got some questions like we can get the questions from the areas like classification of algebraic structures. Yes. So they can give you some algebraic structure and they can frame some binary operation delta is so and so, star is so and so, something like that. And they can frame a question like this. This binary operation star is commutative but not associative. It is associative but not commutative. Or they can say that they are both, it follows both commutative and associative. So that is one type of questions we usually get from the algebraic structure. Even in syllabus also, they simply mention that monoid and group, but we can get the questions from semi-group and groupoid, monoid, groups, abelian groups, and everything, generators concept, cyclic groups, many things we have in our algebraic structures. So usually we can get the questions from that area. But if you observe the recent paper, in our recent paper, we got a question. This is just like related to the statement of a theorem. Yes. So now the trending is in such a way that you should understand the theorems and how to derive the statements. The theorem statement xy whole square. Here you should clearly understand that xy whole square is nothing but it's not like a into xy star xy. So star is the binary operation. Binary operation is just like a heart of algebraic structure, right? If you are okay with the binary operation, you can check any property, closure, associative, identity, inverse, commutative, any property you can say that. And you can say, yes, the given algebraic structure is abelian, group, monoid, semi-group, subgroup, groupoid. You can speak anything like. Am I clear, my dear? So the trending is like this. You observe the question. So they are framing the questions on statements. So what are the available famous theorems in our group theory? You should be focused on that. Yes, once upon a time we got the questions only from the classification of the structure. Maybe they are going to much deeper into it. So statements, they may focus the questions on generators. From the generators also questions available. But now the trending is like this. Please understand in this pattern. Now see this question about connectivity. A simple undirected graph of 10 vertices, if the graph is disconnected, then the maximum number of edges can have. I think it's a standard question from graph theory. So they are asking the question from connectivity. So if the graph is disconnected means, yes, sir, the graph can be disconnected with 3 components, 4 components, or with 5 components, or the disconnected components can be with 2 components, right? Where we can get the maximum number of edges. So we can solve the question like E is less than or equals to n minus k into n minus k plus 1 by 2. Right? Yeah, it's a standard question. Now let us see. The number of arrangements of 6 identical balls in 3 identical bins. Identical balls and identical bins. My dear, we have the concept like division and distribution in our combinatorics. Right now? In division and distribution, you can speak like non-identical objects. Yes, sir. Objects are non-identical. Their shape, color. There are many parameters for your object, right? If in all in all parameters, if it is same, you can call it as identical. So in division and distribution, we have different models. I hope you are recollecting all that. Non-identical objects, they are divided into groups. Sometimes in non-identical objects, they are divided into groups and the group size is fixed and equal. Yes, and next model is group size is fixed but not equal. Right? Sometimes group size is not at all fixed. So dynamically the group size is going to be changed like anything. Sometimes the group size can be 0 and sometimes the group size can be n. N means n or non-identical objects are available. So all this discussion about something called non-identical. But the given question, identical objects. When the identical objects came into your picture, you may think that n plus r minus 1 c or r minus 1, or it may be n minus 1 c r minus 1 like. But here the question is, identical balls with r numbered boxes, whatever the formulas I discussed now, two formulas, n plus r minus 1 c r minus 1, n minus 1 c r minus 1 is also okay. By crossing all these cases, the examiner framed one more question, that is from just like balls and sticks. Identical balls in identical bins. So you need to analyze all cases, my dear. So this is one question we got in recent paper 2022 for 1 mark. Yes. And as I mentioned earlier about generating function, so which one of the following is the closed form of the generating function? Once upon a time, not only in generating function, sometimes there are some papers, they are not even touched the combinatorics also. Yes, sometimes the combinatorics weightage is 0. There is no question from combinatorics if we observe the previous year papers. But now if we observe the latest papers, they are focusing more on combinatorics like recurrence relations, and slowly they are increasing the weightage to generating function also. Every time he is touching generating function, and that too this time in 2022 we got a 2 marks gate question. Yes, so see this question, and the closed form for the generating function. So the function is defined like this. In our sequence an, whatever you say your sequence, something called summation of ai into x bar I, that ai is n plus 1 when n is odd, and that ai is 1 in other cases. Maybe it is even or 0, a naught case, a2 case. So they define some sequence. For that sequence, what is the closed form of the generating function, right? So this is the area we got. Once if you observe the what you call whole trend, we have a questions like they can ask you the expansions of 1 minus 3x whole power minus 1. What is the value of this? And what is the coefficient of x power 27? What is the coefficient of x power 12? We got these type of questions from our generating functions. So I hope you remember the logic. The coefficient of x power 12 is indirectly they are asking the number of ways of choosing 12 objects from the given sequence, something like which consists k objects, a1, a2, a3, so on, ak, where repetition is allowed or something like. So if you are okay with expansions, just like 1 minus x whole power minus k and 1 minus ax whole power minus k. So I hope you are recollecting all the things. If you are okay with all these expansions, you can solve these questions. Once we got these type of questions from generating function. But now the present trend is they are giving this type of question and sequence is defining, and what is the closed form of the sequence. And this model is already touched in previous time also. But many questions are there in expansions, but this is the time they asked for 2 marks this question. So this is the model you should make it of. in your preparation strategy, you try to practice more questions from these areas. These are just like untouched areas. Usually the student don't touch these areas. When he think about combinatorics, his interest is, he thinks about, yes, yeah, I want to go for sum rule, product rule, permutation with repetition, without repetition, combination with repetition, without repetition, other counting principles, pigeonhole principle, dearrangement concepts, Euler functions, Fermat's little theorem. The students think all these things, and after that he will come into the recurrence relation. After recurrence relation, he come into the generating function. Don't do such things. Now the priorities are going to change, my dear. You just give the equal importance when you are preparing combinatorics. You can think all counting principles. You are counting basic counting principles, sum rule, product rule, and permutation with repetition, without repetition, combination with repetition, without repetition, pigeonhole principle, Euler function, dearrangement. These 7 concepts you can treat it as a one level, and you can go for some other recurrence relations second part, and third part is generating function. You divide the combinatorics concepts into 3 equal areas and practice according to that. So that is the suggestion I can give you in your preparation strategy, my dear. I hope you got the point. So now see this question from graph theory. We have a question like this. Consider a simple undirected unweighted graph with at least 3 vertices. Minimum 3 vertices should be there. Order of the graph is greater than or equals to 3. Minimum 3 vertices should be there. And A represents the adjacency matrix of the given graph. Then the number of 3 cycles. My final question is, we want to find out number of 3 cycles. Number of 3 cycles in the graph given by. So they are framing the question on something called adjacency of the matrix. So after adjacency of the matrix, you need to find out a number of 3 cycles. That number of 3 cycles, that is a number, right? Number of 3 cycles. That number of 3 cycles is a trace of something. Say trace of something. Some little knowledge of pure maths is required. Trace is nothing but sum of principal diagonal elements and nothing else. So if you are okay with that, then you can answer this question about adjacency of the matrix. My dear student, whenever they are framing the question from graph theory, so there will be definitely one question from basic concepts, just like this, right? Not only this paper or previous paper or any other paper. So if we analyze the papers like this, they are framing 2 types of questions minimum. One question from basic concepts and one question from any particular concept. The particular concept may be eccentricity, the particular concept may be something about connectivity or matching or independent set or coverings or something like that. So right, so they can frame any question like that. But don't forget the basic concepts, types of graphs, adjacency preservation, and number of 3 cycles, cycle, acyclic, tree, connectivity, spanning tree, and handshaking method, and what do you call our sum of degrees theorem, Havel-Heckmey's result, which of the following is not graphic. So from these all basic areas, every time we are getting minimum 1 question. So we can expect 99.99% from this area. So you can divide our graph theory into 2 parts, like, so all base concepts at one level and advanced concepts, whatever you say, your topology, isomorphism, all that things are second level. So you can prepare, you can do your strategy in that point of view, right? This is the question we have. And yeah, this is the question I talked about Peterson's. So earlier we discussed about Peterson. So this is the question. You just observe how they framed the question, right? So the following simple undirected graph is referred to as Peterson's. This is Peterson's graph, right? So 10 vertices, 2 C3 cycles, degree of every vertex is 3, chromatic number with chromatic number 3. So this is the simple undirected graph, and that is our Peterson's. So from the Peterson's, what they are asking you, just to see which of the following statement is are true. The first statement is about the chromatic number of the graph is 3, and the second option is the graph has Hamiltonian path. Hamiltonian, they are not asking about Hamiltonian graph, my dear, Hamiltonian path. I hope you know the difference, Hamiltonian path. Hamiltonian path may exist, may not exist, doesn't matter. If you want to say the given graph is Hamiltonian, which means that Hamiltonian graph. Hamiltonian graph means Hamiltonian cycle is required. Hamiltonian cycle definitely required. But here they are asking about just path. Right? The covering of all vertices without repetition of any vertex. The vertex, first vertex, maybe you can repeat, you may not repeat, doesn't matter, because I am talking about path, set of edges. Fine. Next, the following graph is isomorphic to Peterson's. Yes, they framed some graph, and this graph is isomorphic to this one. Is it isomorphic or not? Isomorphic in all aspects. In all aspects, the two graphs must be same. Yes, there must be a bijective function. This is G1 graph, this is G2 graph. There must be a bijective function from G1 to G2. Right? And last but not least, observe the last option. The largest maximal independent set size of the given graph is 3. Yeah, my dear, they are asking MIS also. Largest maximal independent set. So you just see in a single question, the examiner touched all areas like independent set, isomorphic, Hamiltonian, chromatic. And they introduced Peterson also. All 4 to 5 areas covered in a single question. That is the beauty of GATE. I hope you got it. Okay, my dear. So this is the question we got, as I mentioned, about Peterson's. And it's a standard question. This is something called about recurrence relation. So consider the following recurrence. F of 2n is equals to 2 times of f of n minus 1. When n is greater than or equals to 1, I can use this function. And n is greater than or equals to 1. And the given f of something, it should be in the form of 2n plus 1. So I can use the definition of 2 times of fn plus 1. So which of the following statement is true? So you can do the iterations f of 1 to f of 10. You can understand which can be which can satisfy. I think it's a MSQ question. Many of the options satisfies, right? So this is the standard question from recurrence. You can count this question in our discrete, and you can also count this question in your algorithms also. To solve this particular question, discrete knowledge is also enough. No further knowledge is required. And if you want to count it in algo, also no problem at all, right? Yeah, and one more question from graph theory. So the adjacency matrix of a simple undirected unweighted graph having the following vertices, they speak about different properties of adjacency matrix here. So in this particular question, a square, the degrees of the vertices and everything. So this is also from the basic concept as I mentioned about adjacency of the matrix. Yes, you can say the adjacency. You can speak about either the first vertex is neighbor to second vertex. Between the nodes, you can frame the adjacency matrix. That is one way of preparing adjacency matrix. And you can also prepare adjacency matrix in such a way that in between the edges and vertices also. You can take edges E1, E2, E3 and nodes N1, N2, N3. You can prepare in such way also. Anyway, we can say that this is the question from basic concepts, right? My dear student, before going to 20 and all, understand one thing. This is 1, 2, 3, 4, 5, 6, 7 and 8. I shown you all 8 questions what we got in the recent paper 22 gate examination. So how they are framing the questions, and you should analyze in such a way that and you should change the strategy according to that. Okay. Sir, I noticed one thing. Maybe one smart student can say like this. Sir, I noticed one thing. All the questions you shown, almost 8 questions I shown, all the concepts came from the concepts like combinatorics and graph theory. Yes, they touched these 2 units and they framed all the questions, my dear. And this is the miracle in our discrete mathematics. Yeah, I am giving training for GATE students more than 10 years. So I did not see this type of papers till now, because all questions came from only 50% of the portion, and remaining 50% he did not touch at all. So he did not given any question from math logic, any question from set theory and algebra. Usually it doesn't happen. It's not a regular pattern, my dear. So when you are making the strategy plan, yes, you can go for standard strategy, that's okay. But according to the exam, in runtime, you need to change your strategy also. I hope you got my point. So all questions came from these 2 areas, and we every year we can standardly we can expect a question from first order logic, that is called first unit. Yeah, let me show the 21 paper. If you see 21 paper, in both set 1 and set 2, you observe this. Sir, in both set 1 and set 2, we got a question from tautologies here, and same tautologies area. We got the questions, 2 questions we got, both are 1 mark question. As I remember that they framed some question about antecedent and consequence, one MSQ question it is. So they framed a question in such a way. And we got a question about types of relations also. Yes, types of relations also. And bijective function question it is. And the functions question also from 2 marks question. So actually in that functions they talked about number of functions, 0 to n minus 1, how many functions are available. From little knowledge of pure maths they introduced there, n by n matrices are there. So how many entries we can frame. So such question we got from functions. And cyclic groups, coming to the groups concept, cyclic group, 2 marks question we got from set 1. And they also touched the question like subsets. Actually you think that yes, maybe this is the question from set theory, but if you go to the solution of the question, that is not actually a subsets concept. They can simply say that A is subset of B, but he asked about number of subsets. Number of subsets means again counting principle come into the picture, and we need to understand that it is from combinatorics actually. Yes, combinatorics, division and distribution, third case, some 3 power n, 3 power 10 answer will come. So such questions we have. So it is a mixture. So they can frame the question from both areas, right? The student, if the student has the knowledge from multiple areas, then only he can answer that question, right? And he touched the concept like eccentricity. Yeah, eccentricity concept, distance between the nodes and the shortest path available between the nodes. And in that shortest path, what is the maximum is called distances. In that all distances, in that maximum available paths, what is the shortest path, that is called distances. From that distances, what will be the maximum, that is called eccentricity concept. So eccentricity, diameter, radius, circumference, girth. So from that concept, they framed a question on that in set 1 paper. And quality score. And from the concept like quality score, the product of the edge weights also, we got a question from set 2. And a planar graph standard question it is, 1 mark from set 1. My dear, in 21, if you observe that, he touched something called mathematical logic here, set theory and algebra, groups here, yeah, groups concept here, and eccentricity graph theory, and this is also graph theory, this is also graph theory, and set theory and combinatorics, just one question you can count. So he touched all areas. This is called standard paper. Usually the paper is like this, right? So we can go for standardization. Most of the cases the paper will be like this. We can guess the paper some level, right? Yeah. So this is the weightage we got. Here we got 9 marks from set 1 and 7 marks from set 2. In similar pattern, let us see 20 analysis also. In 2020 paper also, discrete is having very good weightage. The weightage is 9% here. So if you observe all the subjects, subject-wise weightage I have given here, you can understand the weightage. And after 20, I think I can go for some standard paper like 18. Yes. Yeah, my dear, if you observe 18 paper, this is the, one of the standard paper we have. So in this paper, if we observe our discrete mathematical structures, discrete mathematics and graph theory. Yes, many of the universities, it can be named as DMGT or DSGT subject, discrete structures and graph theory like, DSGT like. Okay, sir, in our discrete structures, we got a question from first order logic and trees concept, graph theory. From graph theory, we got a question from chromatic number, from set theory and spanning trees. My dear, in papers, I am talking about the concept. From this discussion, you should understand what are the areas you should not leave. These are very, very necessary areas in your preparation. So whatever the strategy you follow, these type of things you should not omit it at all, right? So first order logic, without preparing first order logic concepts, you prepare total mathematical logic, that is not at all advisable. That is not at all advisable, right? Some students ask me that, sir, what are the important concepts, what are the thorough concepts I can say. Just now you watched that latest paper 22 and 21 and 20 and something called 18 paper we are watching. My dear, we cannot say that these are the concepts compulsory. If you prepare these concepts, yeah, there ends the matter. You definitely get a very good top rank in GATE. No trainer can assure that in my point of view. But what we can say is we can predict the paper by analyzing. With our experience, we can analyze some level we can analyze. So we can say that when we have the less time, yeah, once upon a time I can say like this, yeah, you can prepare math logic and graph theory, minimum 4 marks you will get. Yes, there is no false in that word. And now also you are getting the questions from graph theory, and the importance of graph theory is in consistent way. That's okay, fine. But coming to math logic, once upon a time, definitely there will be a question from first order logic. But in recent papers, we did not find. In 2023, let us suppose if all the questions came from math logic and set theory and algebra, even they did not touch the concepts like combinatorics and graph theory. So it's not at all surprise to us, because he already touched such, he already framed such type of paper. So my dear student, understand, in our standard strategy, what we are going to do is, the concepts which are most important, which are most frequently visited in the examination, so such type of concepts we should not leave at all. We should be very strong in that. And at the same time, you should be strong in remaining concepts also. You should not at all leave that concepts. And particularly, you know that if you prepare any class notes, any subject, you can go for any subject. If you take any subject class notes, almost the faculty can finish your task somewhat 90 to 95%, you can finish the task. Yeah, my dear. Yeah, as you know that ACE is the premier league institute in our India. So in our ACE Academy, you can go for any subject, any faculty notes. If you go through that, almost 90 to 95% of the questions came from the classwork only. Classwork in the sense, not exactly numericals and everything. So the model of the questions are definitely available, and the roots, what are the base for that concepts, definitely available in your class notes. So you can cover 95% of the questions, and I can confidently say that. And it is more than 95% also in some aspects, but still I don't want to exaggerate. I want to say that to cover all subjects, I can say that 90 to 95%. So when you are okay with 90 to 95% from all areas, if you are okay with classwork, when you are taking the test series and other mock test and other examination, you can go for divergent. You can go for divergent. There you can find the different questions and variety of the terminology, and the same question, how the connective questions are available. So you can go through the standard pattern first. After going to the standard pattern, you can go for divergent, my dear. That is the thing I am suggesting. Standard pattern in the sense, you take any subject, for example, SQL is there, SQL question from database management. A student is preparing database management without preparing SQL and transaction management. Is it advisable? A student is preparing digital without K-maps and Boolean algebra. Is it advisable? A student is preparing without grammar TOC. Is it advisable? I hope you got my point. So the pipeline concept in computer organization, and queues concepts in programming, and scheduling concepts in operating system. Let us suppose I prepared all divergent questions in operating system, but I did not touch the FCFS scheduling. Not only FCFS, all schedulings, preemptive, non-preemptive, all CPU schedulings. I did not touch the page replacement algorithm. I did not touch the paging concept. Without touching these three concepts, you prepared all whatever you say, deadlocks, memory management, whatever, you prepare all the things. Is it advisable, my dear? Is it advisable? My dear, what I am saying is, in 2018 or somewhere, we have the standard papers. Most frequently, they touched that concepts many times, more number of times. So you should not leave such concepts at all. So you should be very, very strong in that concept. In that concept, what are the divergents are available? You can go through that. You can go through that, no problem at all. But without preparing, these concepts should not go for other concepts. I am not saying that these concepts are sufficient. I am just saying that these are necessary. These are necessary, my dear. That is the point. You should make it off, right? So let us come to this. I want to say first order logic, one question from graph theory, one question from math logic, one question from graph theory, one question from set theory, and one more question from spanning tree, that is also graph theory, and there is no question from combinatorics. Yeah, many papers are there like this. Got it, my dear? Yes. And not only the recent papers, if you go 10 years ago papers like 2012, 13, 14 also, the discrete weightage is still consistent, my dear. I hope you got it. In 12, we got 18 marks from discrete. Here, discrete in the sense, that time they simply mentioned discrete maths. They include engineering also. Even engineering, you may get somewhat 5 to 6 marks. You can expect 5 to 6 marks like. And remaining questions from our discrete structures only. In 2013, they given 13 marks. In 2014, we got 16 marks from discrete. Am I right? Let us suppose there is one average student and he covered discrete, and he covered algorithms, and he covered something called aptitude, right? This is a dedicated area, right? So aptitude, every time 15 marks question will come. So 15, 16 plus 10, 60, 26 plus something called 15, and he covered almost 41 marks from this area. Am I right? Let us suppose there is some other student here also, he covered 13 marks here and 10 marks, either OS or this one, and he covered 15 marks. He can also score almost 10 marks, 40 marks like. So let us suppose, let me take 110 here. So 10 plus 13, 23, and 23 plus 15 here, right? And again you got the marks like this. And here I think in the 12 there is a very good weightage for database. So database 18 here and 15 here. Let us suppose an average student, if he prepare just 3 concepts, if he is okay with this, I think this one and this one every time standard. And if you choose 1 or 2 subjects, either your favorite or high weighted or whatever you say, it is not at all a difficult task to qualify GATE with a good score. And once not only qualifying, if you are able to answer more than 40 questions out of 65 questions, so there is a very good chance 45, 50 questions you can aim for premier institutes also. And first of all, you should understand, if you have the proper strategy, it is not at all a difficult task to qualifying in GATE. Okay, my dear. So I hope you got these things. Sir, in these scenarios, sometimes we are getting more marks. Sometimes every time weightage wise, we can expect 8 to 12 marks from discrete. So there is no change at all. But here, what's the actual strategy coming to the deeper way of discrete? So what is the proper plan I can follow? My dear, don't go for your probability, calculus, linear algebra. Here I am talking about discrete only. So your probability and linear algebra, calculus part will come under engineering mathematics, pure mathematics. In our discrete, we can divide the portion into 4 units like math logic, set theory, combinatorics, and graph theory. Yeah, let us go much deeper into it. In math logic, I have 2 things, propositional logic and first order logic. I can suggest you one thing, in our propositional logic, you don't leave the questions like tautology concept. And in first order logic, the rules of inferences, and such thing like multiple quantifiers, you should take more care of these concepts. So here I written rules of inferences, that rules of inferences for both propositions and quantified statements also. Yes, I am talking about quantified statements. Whatever you are saying, universal instantiation, universal generalization, existential instantiation, existential generalization, including that 4 rules, direct proof, indirect proof, everything. So that rules of inferences, multiple quantifiers, order of the quantifiers. So such things you should take more care of. It doesn't mean that leave the remaining topics. In your preparation strategy, we should be very careful about these topics. Whatever the question came from this area, we should not at all leave, because it is most expected, very frequent question, how we can leave from this area. And coming to set theory and algebra, in set theory, we have the concepts like sets, relations, functions, partial orders, lattices, monoids, and groups, right? So in set theory, My dear, you focus more on the concepts like power set and subsets. Yes, sometimes we are getting the questions from subsets concepts also. The concept is very simple, subset, but they are framing a level question. They really want to test the student, either the student is clear about the concept or not. Yes. So that is power set concept, and after power set, you should think about subsets concepts and multi-sets and partitions. Partitions is also one of the important concept we can say. In relations, you can go with the types. The types of relations, the basic concepts, every time we are getting a question like a number of functions, number of functions. Number of functions, it seems to be simply n per m, but they are framing a question in such a way that the number of functions which can be composite, g over f, f over g, in any pattern they can ask. And coming to partial order, they can ask the question from partial order in any pattern. They can give some question, the given structure, yes, it is a poset, it is not a poset. Something they can frame a question, and sometimes they can give the relation in a proper way. After giving the relation, they can ask you the number of edges in your poset, the number of edges available in your Hasse diagram. X is the poset name, R is the relation name, I can say, right? And coming to lattices, in lattices, sometimes they can give the structures, the questions like structures. From that structures, they can ask you a question like, this structure is what type of lattice, joint semilattice, or meet semilattice, or bounded semilattice, or it is complemented lattice, or it is distributive lattice, it is Boolean algebra structure. So they can ask you the questions in different pattern. And if you observe that there are some questions like mixed questions, they are asking about something called refinement. So these type of questions you focus more, because in refinement he can touch lattices concepts and also your partitions concepts, pi 1, pi 2, pi 3, and in the poset diagram he can also touch poset. Yes, he can frame a relation like this. A set is refines to another set if and only if it refines. Yes, a set is related to another set if and only if, yeah, pi 1 is one partition, pi 2 is another partition, pi 2 refines, pi 1 refines pi 2, then I can say that there is a relation exists between pi 1 and pi 2. So such model questions, in that one question, he touched all your sets, partitions, power set, and lattices, poset diagram, everything. So such model questions you should take it off. And coming to the algebraic structures, in our GATE syllabus, they simply mention that it is monoids and groups, right? But we may get the questions from semi-groups, subgroups, many possible questions. They are asking abelian group, and present trending, they are asking about the statements of the theorems also. So you should be aware of proof and derivation of the statement. So that thing I can suggest. If you are okay with that, then it will be very good, right? So usually the classification from the types of the groups, from the types of the algebraic structures, we can get a question. And sometimes they can ask the question about a binary operation. And the binary operation with the properties. The given binary operation is so and so. Yeah, it is associative but not commutative. Such model question is a standard question. So you prepare such type of models in a very good practice. Yeah, my dear, that is about our set theory concepts. And coming to combinatorics, as we discussed earlier, in combinatorics, in counting you can take all the concepts. That is one level, right? So your permutation with repetition, without repetition onwards up to dearrangement, that is one level. And let us make a second note of recurrence relation. Recurrence relation, they can give you the recurrence relation, what is the solution to the recurrence relation, such model. And generating function, how they are asking the closed form of the given generating function like. So such discussion we already did about combinatorics. So you can see the question like that. So in countings also, some questions like pigeonhole principal questions, Euler function questions, dearrangements questions. So don't leave such areas. That is the easy area, you can easily score from that area. Don't leave that areas. Okay? Yeah, fine. And coming to our graph theory, in our GATE syllabus, it seems to be just like three concepts, matching, coloring, connectivity, but actual scenario is different. So from graph, we have many basic concepts, and also Euler graph, Hamiltonian graphs. Yes, yeah, I can mention something. So Euler graphs, and Hamiltonian graphs, planar graphs, isomorphic graph. Let me write isomorphism. So here he simply mentioned matching, but you should be aware of all concepts related to matching, matchings, coverings, independent sets. Yeah, largest maximal independent set. So in recent exam also they asked a question from independent set, but it is not a size of largest maximal, it is the smallest maximal independent set. They framed a question in such a way. And some other concepts like topology, and we have the connectivity concepts, and after connectivity don't leave the basic concepts. All your basic concepts, which is graphic, which is not graphic, and graph coloring. And these are the important areas, my dear. You should be good in our graph theory. So in your preparation strategy, you give importance to these areas and prepare a proper plan and spend accordingly, according to the weightage and all. Weightage is going to be varies, but there are some concepts you may be noted of. Some concepts is having consistent weightage. So such concepts you should not leave. Sometimes it is varies, I can understand. But in similar way, some areas they did not, they are not decreasing the weightage to that concepts. Every time they have good weightage. For example, graph like. So you can practice more on this, right? Yes. Sir, not only about our graph theory and all, let us go for overall view. In our CSE portion, we have some 10 sections like, so in our 10 sections, if you cover this area, mathematics and aptitude, almost we can guarantee for 30 marks from this area. I am writing 30, just minimum 30. So this is 15 compulsory. And if you include discrete and pure maths, it can be 18, 16. You saw many papers, right? Or at least in worst case, let us make it as 15, right? And there are some concepts like digital, computer organization. You can choose any one or two subjects from this. So you can get somewhat 10 marks from this area. And in your preparation also, when we have the concepts like digital and computer organization, these two topics are just like interlinked subjects. Connectivity, more connectivity is there, right? More areas are common, right? When you are taking about conversions and all number theory concepts, all are same na, in both subjects. So examiner is also having the similar choice that he can frame a question which can cover both subjects. So when you are preparing a subject, means you prepare both subjects, that is somewhat advisable. So preparing only one subject is not like, you can prepare both programming, data structures and algo. So algorithm is having very good weightage, that's okay, fine. Maybe sometimes we got a question from algorithm which is interlinked with DS, and data structures and algorithms, you cannot separate them, right? You cannot separate them. Yeah, in algo we have somewhat concepts like somewhat theoretical concepts, divide and conquer. Many concepts are there. That's okay, fine. But in our data structures, whatever you are talking about, linked list, double linked list, and all the concepts, sorting techniques, merge sort, quick sort, and all sorting techniques. And in our programming, what we have the most expected like recursion concepts. These are interlinked concepts. So examiner can easily frame a common question. The student can answer that question if he is okay with all these three areas, then only he can answer that question. So that choice is really how the examiner. So my advice is go through all this link. If you want to start one subject, if you are able to cover all subjects, it's something like satisfaction. You can understand, yes, whatever may be the question, I am okay with that. Whatever it may be interlinked question, more connectivity is there, na, more chance you have. I hope you got it. Yes, and this is section 5 and we have 5 more sections, my dear. Theory of computation, compiler design, operating system and database and computer network. Yes, last 3 subjects are just like a, what do you say, beautiful subjects. They are independent subjects. In our database, we can guarantee that there is a question from SQL, one question from transaction management. Sometimes they can frame the question in any way. Most expected questions I am talking about. When the networks, we have the question from TCP, IP, protocols, routing. So such questions are there. And that too, what I am saying is the chance of the getting question is independent. Usually they don't mix the question. If the examiner wantedly mix the question from the operating, he is taking a concept like paging, that paging is mixed with computer organization wantedly, we cannot say anything. But the chance I am saying, chances are very less when comparing with other things. Other things means theory of computation and compiler design, they have the connectivity. Like just like base subject and advanced subject, they have the connectivity. Na? When the student is preparing TOC, if he prepare compiler design also, then it will be good for him. In your preparation strategy, you should maintain this link, my dear. So link of the subjects, that helps you a lot. Yeah, I hope you got somewhat idea about your things. Let me check your messages once. Just give me a moment. Okay. Okay. Thank you very much, students. That's about our today's session. In today's session, we did the deep analysis of the recent papers and we discussed some questions, how they are framing the question and what is old trend and what is a present trend. And we discussed and we compared. And next we went into the much deeper into the discrete mathematics concepts and most expected concepts. What are the things we need to focus more, and after that we came to the overall syllabus of CSE, and for a CSE student what is the strategy you should follow. So yeah, that's it. That's about today's session. Thank you very much for your valuable time. On tomorrow's session, same time at same place, we can meet online. We can discuss some important concepts about discrete. Conceptually we can discuss. Okay, yeah, fine. Have a nice day. See you.